Welcome to part 3 of the Breeding Value Predictions module of TLR at the University of Pretoria. In part 3, since we have in part 2 looked at the construction and also the calculations used after the construction of the mixed model equations in matrix format, part 3 will basically be two assignments that you have to complete before moving on to part 4. So I will just go with you through these assignments for clarity's sake, but please do not move on to part 4 until you've reached a point that you are familiar with the construction of the matrices as being conveyed to you in part 2, and also use a spreadsheet or another means to calculate or to get the inverse of the A matrix, get the inverse of the coefficient matrix, multiply it with the right hand side and get a column vector of solutions. First then the levels of the fixed effects and also the each and every animal's breeding value or additive value. So please then I will then continue to just go through the assignments with you, and that then will at the end will then conclude my part at least of part 3 of this breeding value predictions module of TLR. As I've said, this third part then of the TLR course on breeding values, or the introduction into breeding values, will consist of going through with you through the assignments that you please have to do before moving on to the next part. The first assignment is an example where we have 5 young bull calves that were subjected to growth tests. So they are already weaned, they are older than 7 months, let's say 8-9 months old, and they are put into 2 different growth tests. So immediately we see that we have 2 levels of the fixed effect of test number. So you need to use those 2 different levels of the fixed effect test. What we observe, our phenotypes that we record, in this case is average daily gain. So each of those bull calves in the 2 growth tests will have an average daily gain, how much they gain on average per day during the growth test. They are the progeny of 2 sires and 4 dams. So you will see when we look at the columns or the observations that 2 bulls are full brothers. So what you need to do is to set up the mixed model equations, and we will then look at the table on the next slide, and the heritability estimate for average daily gain, or ADG, is 0.8 or 80%. So you need to construct alpha from the knowledge that the heritability estimate is 0.8. So let's then look at the table, giving us the information of these animals, these 5 young bulls. So these are our animals, animal 1, 2, 3, 4, and 5, and you will see that the first 3 animals were tested in a growth test. We call it test 1, and the next 2 were tested together in a different growth test. So we have the 2 levels, the 2 growth test levels. These are the parents of these young bulls. So sire 10 sired animal 1, and also sired animal 4, and sire 11 sired the other animal 2, 3, and 5. So you can already see that you have sibs here. Dam 20 was a dam of animal, or is a dam of animal 1, 21 animal 2, 22 animal 3, 23, animal 4, and then you will see that dam 20 is has two bull calves, one in test 1 and one in test 2. These would be the average daily gain. This is in gram, so your breeding values will be in gram. The first animal grew at a rate of 830 grams per day, second one 910, and so forth. So these were your right hand sides, will be your right hand sides. And as I've said, the heritability estimate for this specific trait is 0.8 or 80%. Okay, so what you need to do then is you need to first construct all these matrices. You start with your x prime x matrix. Remember, that would be the number of observations per test, in this case on the diagonal, and zeros on the off diagonals. And then z prime x would be each animal. Remember, the parents who do not have observations will have columns, and there will be zeros in those elements. So please start then with your first two sires, or your first sires and then your dams, and then only start with the animals. Don't start with the animals in columns. Start with the parents first and then the animals. And each animal that has an observation, our 5 animals, will have a corresponding 1 for the row, in this case of test 1, and a 0 in the row of test 2 if its observation was in test 1, but it will be the other way around if the observation was, or the measurement was, in the second test. And then you have to, if you construct z prime x, you can just as well do the transpose and teach yourself how to do the transpose in a spreadsheet, so that you don't need to retype them all. Then you also have to construct z prime z. Remember, it's a square matrix, starting again with the parents and then the animals, each with a row and a column. And on the diagonal for the parents you will have a 0, but for each animal that has a recording you will have a 1 on the diagonal. Then construct A and do it very carefully. Start with basically with your z prime z, or a column and a row for each animal. And again, remember, always start with the parents on the left and the top row and the left column, your first parent, then your second parent, then your third parent, and so forth, and end up with your animals. Don't start with the animals, otherwise you will not be able to construct A, you will not be able to construct z prime x or x prime z. Once you have constructed A, you then need to get the inverse of A. So use a spreadsheet, get the inverse of A. Remember, you must calculate alpha. You know the h squared is 0.8, so you have to calculate alpha. Multiply alpha with A minus 1. Add them up into z prime z. Construct this matrix on your spreadsheet. Then you have unknowns. You will have 2 levels of B, test 1, test 2, and you will have A's for each of the animals, starting again with the parents, ending up with the animals with observations. The top 2 rows in your right hand side column vector would be adding up all the ADGs, average daily gains, for the first test, the same for the second test, and then you start with parents first. In this column, parents first, zeros because they do not have average daily gains, and you end up with your 5 animals with observations. So you need to construct all these matrices. This is your mixed model equations, your coefficient matrix, your column vector of unknowns, your column vector of the summation of your observations for the 2 levels in this case, and then zeros for the parents and your actual recordings for the animals or the average daily gain for those animals. So you need to construct these matrices first, and then once you've done that and you get the inverse of your coefficient matrix, you multiply it with the right hand side, your two top rows will give you the blues, and the rest of your rows will give you the blubs, for first for the parents and then for the rest of the animals with observations. So that then concludes the first assignment. So please, before moving on with these slides, you can basically pause here. Before moving on, make sure that you are familiar with the construction of the matrices. Make sure that you are familiar with the calculations, the matrix calculations, and make sure that you know what the blues and the blubs result mean that you get from these calculations. That then brings us to assignment 2, and assignment 2 is the example of 8 dairy cows in 3 different parities. Parity 1, so that's the first calvers, parity 2, and parity 3. First calvers, second calvers, and third calvers. So 8 dairy cows in those 3 parities, and this is a 305-day corrected milk yields of those females, and we want to predict breeding values for them and for their parents. They are the daughters of 3 different sires and 7 different dams. So you will have some full sisters among them. And the H-square, or the heritability estimate for milk yield, lactation milk yield in this case, we assume to be 0.3 or 30%. So obviously there's an assignment, and this table then gives us all the information we need, that plus the heritability estimate. So our animals are animal 20 to 27. Those are our animals, and they are sired by sire 1, 2, and 3. So this female's sire is sire 2, and that female's sire is sire 1, and their dams would be dams 11, 12, 13, 14, 15, and so forth. So these would be then the dams of these animals. You will see that animal 1 is in a third lactation, third parity. Animal 21 is in a second lactation, animal 22 in a third lactation, and so forth. So these would be the parity, and this will be the total 305-day corrected milk yield for each of these animals. So animal 20 gave 8,110 kilograms of milk during a third lactation. So using that, you need to present the blue effect for parity. So you need to construct all your matrices like you did for assignment 1. You have to do the matrix calculations after you have done the inverses and you've multiplied by the scalar of alpha, and you have to then calculate the blue values. So that's the effect of parity. And you also have to calculate the blood breeding values for each animal. Remember again, always start with the parents in constructing these matrices, and then you can indicate which bull will give you or present progeny with the highest value for breeding value for the trait, the 205-day milk yield, and also make your pick amongst these animals in terms of the cow with the highest breeding value for milk in this case. So please do not move on to the next part unless you are familiar with these assignments and you know how to construct these matrices, and you know how to do the matrix calculations and how to interpret the results of these assignments. So good luck with your assignments. This then concludes our part 3 of the breeding value prediction module of TLR at the University of Pretoria.